Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about the chemistry practical, and this practical is very important for 10+2. So objective of this practical is to use a standard laboratory measurement device to measure length, volume and mass amount. The next, to use these measurement to determine the areas of shapes and volume, to determine the density of water, to determine the density of a solid, use this to determine further quantities, to determine the density of aluminum, applying the techniques of water displacement, and use that value to determine the thickness of a piece of aluminum foil. So, chemistry is the study of matter. Our understanding of chemical process, which depends on our ability to acquire accurate information about matter. And this information is quantitative in the form of measurements. So, some common measurement device and learn how to use them to obtain correct measurement, each with correct precisions. A metric rules will be used to measure length in centimeter. So all measurement devices are subject to error, making it impossible to obtain exact measurements. The student will record all the digits of the measurement using the making that we know exactly one further digit that we estimate and call uncertain. The uncertain digit is our best estimate using the smallest unit of measurement, giving the estimating between two of these values, and these digits are collectively referred to as significant figure. So the electronic balance is designed to register these values, and students should only record the value displayed. When making measurement, it is important to be accurate and precise as possible. Accuracy is a measure of how close an experimental measurement is to the true accepted value. Precision refers to how close repeated measurement using the same device are to each other. So you can see here, this is your scale. Here ruler making are very 0.1 centimeter. The correct reading is 1.67 centimeter. So first two digits 1.6 are known exactly. 1.6 are known exactly. The last digit 1.67 is uncertain. You may have instead estimated as it is 1.68 centimeter. Is like that. So the measurement device used in this measurements have different scale deviation than the one shown. Precision is basically how many significant figures you have in your measurement. To find the precision, you basically take the smallest unit on your measurement device and add decimal places. So in general, the more decimal places provided by a device, the more precise the measurement will be. So measurement obtained in this lab will often be used in subsequent calculations to obtain other values of interest. It is important to consider the number of significant figures that should be recorded for each calculation values. If multiplying or dividing measurement value, the result should be reported with the lowest number of significant figures used in the calculations. If adding or subtracting measurement value, the result should be reported with lowest number of decimal places used in the calculation. So significant figure in calculation value, calculated one. The student run 18.752 meter in 54.2 seconds. So calculate its velocity or speed. So what have the formula of velocity? The velocity is equal to distance divided by time. You have 18.5752 meter divided by 54.42 seconds. So this is the meter per second from calculator. And this is the 3 significant figure, which is your answer. So the mass of a glass is measured to be this much grams. If 10.3 gram of water are added to the glass, what is the total combined mass? So total mass is equal to this plus this. So from the calculator, this, and you have to answer into decimal places. So this is the significant. So students will also determine the density of water as well as aluminum. Volume is the amount of space occupied by matter. An expensive property is one that depends on the amount of matter present. Volume is an extensive property. So my friends, how you calculate this? The volume of a liquid can be directly measured with a specialized glass beaker, typically in the unit of milliliter or liter. In this lab, a beaker, 2 graduated cylinder and burette will be used to measure liquid volume, and their precisions will be compared. You know, when measurement liquid volume, it is important to read the graduated scale from the lowest point of the curved surface of liquid, known as the liquid meniscus. For example, here you can see measuring the volume of liquid. Here the graduation cylinder marking are every 1 milliliter. When read from the lowest point of the meniscus, the correct volume reading is 30.0 milliliter. The first 2 digits 30.0 are known exactly, this 30. Last digit 0 is uncertain. Even though it is a 0, it is significant and must be recorded. So the volume of a solid must be measured indirectly based on its shape. For regularly shaped solids such as cube, sphere, cylinder, or cone, the volume can be calculated from its measured dimension, length, width, height, diameter, by using appropriate equation. You know formula for calculating volume of regular shaped solid. The volume of cube, L into W into H, and volume of a sphere 4 by 3 pi r cube. So here where r is equal to radius is equal to half the diameter, and volume of cylinder pi r square h. So for irregular shaped solid, the volume can be indirectly determined via the volume of water or any other liquid that the solid displaces. When it is immersed in the water, Archimedes principle, the unit for solid volumes are typically cubic centers or cubic meters, or 1 ml is equal to 1 cubic centimeter, measuring the volume of irregular shape solid. So volume of water displaced, you can see here, after adding this water level is going up, and this is the displacement. So what will happen here? The volume water displaces is equal to the difference between the final volume and initial volume. So final minus initial, you will get the volume. So volume water displaced is equal to the volume of solid. Now define the density. You know, density is defined as the mass per unit volume of a substance. Density is a physical properties of matter. Physical properties can be measured without changing the chemical identity of the substance. Since pure substance have unique density value, measuring the density of a substance can help identify that substance density is also an intensive property. An intensive property is one that is independent of the amount of matter present. For example, the density of gold coin and a gold status are same, even though the gold statue consists of a great quantity of gold. Density is determined by dividing the mass of a substance by its volume. So density is equal to mass by volume. So density is commonly expressed in unit of gram per cubic centimeter for solid, gram per milliliter for liquids, and gram per liter for gases. Now what is the procedure? Metric ruler or shape sheet, electronic balance, triple beam balance, 250 milliliter Erlenmeyer flask, 100 milliliter beaker, sugar, 400 milliliter beaker, scapula, burette, 10 milliliter and 100 milliliter graduated cylinder, 100 milliliter beaker, wooden block, aluminum pellets, aluminum foil, electronic balance, distilled water. For safety, be careful when adding the aluminum to your graduated cylinder, as the glass could break. Personal protective equipment (PPE) needed. Lab coat, safety goggles, closed-toes shoes. So first part, measuring the dimension of regular geometric shape. Borrow a ruler shape sheet from front bench. Record the ID code on your report form. Measure the dimension of two geometric shape, length and width of rectangle and diameter of the circle. Record these values on your lab report. When finished, return the ruler and sheet to the front bench. Use your measurement to calculate the area of each shape. Area of rectangle, A is equal length into width, and area of circle, pi r square. Then you need to measure mass of solid. So obtain a 215 liter aluminum flask from your locker. Use the triple beam balance to determine the mass of this flask. Use the electronic balance in the weigh room to determine the mass of the same aluminum flask. Be sure to record your measured mass on your lab reports. Then weighing by difference. Obtain 100 ml beaker from your locker. Use the electronic balance in the weigh room to determine the mass of this beaker. Add 2 spoonfuls of sugar to this beaker. Use your scapula. Do not do this over the balance. Determine the new combined mass of both the beaker and the sugar. Be sure to use the same electronic balance as before. When finished, dispose the electronic sugar in the sink. Use your true measurement to calculate the mass of sugar only by difference. Now, volume of liquid and solid. Volume of liquid. At the front bench, you will find a burette, 10 milliliter graduated cylinder, 100 milliliter graduated cylinder, and 100 milliliter beaker, each filled with a certain quantity of water. Measure the volume of water in each. Remember to read the volume at the bottom of the meniscus. It is useful to hold a piece of white paper behind the burette, cylinder, beaker to make it clearer. Now, volume of regularly shaped solid. Borrow a wooden block or cylinder or ruler from the front bench. Measure the dimension of the block. It is a cube or rectangular box. Measure its length, width and height. If it is cylinder or cone, measure its height and diameter of its cylinder base. Return the block or ruler to front bench when finished. Now part D, density of water. Using the electronic balance in the weight room, determine the mass of a clean, dry 100 milliliter graduated cylinder. Pour 40 to 50 milliliter of distilled water into the graduated cylinder and weigh. Make sure that outside of graduated cylinder is dry before placing it on the electronic balance. So measure the liquid volume in the cylinder. Use the mass and volume to accurate density of water. Now, density of aluminum and thickness of foil. How you do? Using the electronic balance in the weigh room to determine the mass of clean, dry, small beaker. Obtain 20 to 25 aluminum pellets from front bench. Transfer pellet to the beaker, weigh in the previous steps, and measure the mass of the beaker and pellet together. Pour 30 to 35 milliliter of water into your 100 milliliter graduated cylinder. Precisely measure this volume. Carefully add all the aluminum pellets to the water, making sure not to lose any water to splashing. Also, make sure that pellets are all completely immersed in the water. Measure the new volume of the water plus the pellets. When finished, retrieve the dry and aluminum pellets and return to them in front bench. Analysis. Use your measured mass volume obtained via water displacement of the aluminum pellets to calculate the density of aluminum. Now, thickness of aluminum foil. Borrow a rectangular piece of aluminum foil ruler from the front bench. Use the ruler to measure the length and width of the piece of foil. Fold the foil up into a small square and